Welcome to the first lesson in the Mr. Circuit Lab 3 called Digital Logic Gates. All computers and smartphones are full of digital logic gates, even millions of them. The Mr. Circuit Lab 3 was created to help you gain an understanding of the digital logic gates. By understanding these logic gates, you will be able to participate in the design and maintenance of digital electronic devices. Decisions in life are made by considering the facts, the inputs. A digital logic gate is an electronic circuit that receives inputs, and based on those inputs, it will give you a decision, an output of true or false. There are only 8 digital logic gates. Here are their names: yes, not, and, NAND, or, NOR, XOR, and XNOR. The only type of inputs that you can give to a digital logic gate is a true or a false. In this lab, we are going to explain all of the digital logic gates and the rules for each one. Then, as part of your training, you will assemble an electronic circuit for each digital logic gate. As one example of a rule, the AND digital logic gate requires that all of its inputs have to be true to give you a true on the output. Digital logic gates have only 2 possible outputs, either a true or a false. We refer to the true or false as logic states. In electronics, a true state is when there is a voltage on an output or an input, and a false state is when there is no voltage on an output or an input. With electronic digital logic gates, we designate a true as a 1 and a false as a 0. We sometimes substitute the word high for a 1 and low for a 0. The yes digital logic gate. What is digital logic? Let's look at some examples. First, the yes gate. The rule for a yes gate is if the input is true, the output will be true. And if the input is false, the output will be false. Here is the symbol for a yes digital logic gate. The symbol looks like an arrow with a line on both sides. The line on the left represents the input. The line on the right represents the output. A yes gate only has 1 input and 1 output. Here is the truth table, which shows all the possible combinations of inputs and outputs. In the case of the yes gate, there are only 2 possible inputs, a 0 or a 1, and the same goes for the outputs. Now let's talk about building an electronic yes logic gate. Here is a schematic diagram for an electronic yes digital logic gate. In this Mr. Circuit Lab 3, as part of your training, you will construct this circuit on a solderless circuit board. Before you assemble the circuit, let me explain it. You will notice that this circuit has 1 transistor, 1 LED, 2 resistors, a 9-volt battery, and a normally open push-button switch. The switch turns on and off the voltages of transistor Q1. In this circuit, when the LED is lit up, it means a true is on the output. Let's talk about the transistor. Remember that when a transistor is forward biased, it means that it has all the correct voltages on its pins to allow electron current to flow through it. An engineer designed this circuit such that 2 resistors are in the right values to cause the correct voltages to be on each pin of the transistor when you press switch S1. Note that the arrow on the transistor symbol actually points in the opposite direction of the current flow. When you press switch S1, the transistor is forward biased, and there are two paths which carry current through the transistor. One path from the emitter through the base, and the other path is from the emitter through the collector. The current coming out of the collector pin goes through the LED, through resistor R2, to the positive of the battery, and lights up the LED. When the LED is lit up, it indicates a true, or a high, or a 1 on the output. When you release switch S1, you remove the voltages from the transistor and the LED turns off, indicating a low on the output. So, as you can see from this explanation, this circuit works like a yes digital logic gate. When the input is true, the output is true. Now that you understand how the electronic circuit for a yes logic gate works, you are ready to build one on a solderless circuit board following the step-by-step instructions in the Lesson 1 booklet in the Mr. Circuit Lab 3. Let's see if you can make it work. First the theory, then the application. The world needs lots of people who know, understand, and can work with digital logic gates. There are 7 more digital logic gate lessons in the lab. When you complete this lab, you will have earned a certificate of electronics training for your resume. We hope that you are enjoying this lab and will want to learn more. This lab is available at www.mrcircuittechnology.com.